Okay, guys, you're going to start with the perpendicular bisector. You want to open your compass. How far? How far do I open my compass for this segment? More than half. No, you don't open it the whole way. You have to be more than half. Now, a good idea is to maybe go 2/3. This is about 2/3. I would say it's a little further than it needs to be. You actually need to do this yourself. You can't just watch me do it and then hope to be able to do it. It will not work. More than halfway. This is about halfway, so I would go just a little more than that. Now, in your textbook, what they like to do is they like to draw an arc on the top, and then they draw another arc on the bottom. I think it's a lot more work than just simply drawing the whole arc. This does not have to be a dark arc here. It doesn't have to be dark. It just has to be dark enough to see it. You want to just be able to see it. The trick for your compass is to drag it. You want to drag it across your paper. And you want to go from the other side and drag it across your paper. Again, in your book, they put an arc on the top and an arc on the bottom like this, but you might as well just draw the whole thing in. Now, what I get are two intersections. One, this intersection and this intersection of my arcs define what we call a perpendicular bisector. You don't need to draw this one dark either. This one, we can draw it nice and light. And it has two really important properties. This line, and I'm going to make it a line by putting arrows on it. This line cuts this segment into two perfectly equal halves. It defines my midpoint. And because it's perpendicular, it is exactly 90 degrees from that segment. All those things. Well, it should. Now, when we do an angle bisector, we do something very similar. There's a lot of similarities between the two. And in fact, I'm going to show you guys something where I can make them look almost identical. Gary, you already did your angle bisector? You did? You can make your arc any size. It doesn't matter how big. I generally go about halfway across my angle, from maybe halfway to my points out here, or my arrows. You make an arc across the angle. What this does is it defines 2 points where this distance is the same as this distance, because they're the radius of a circle. Now what I do, I want to go more than halfway across my angle, which I clearly am, and I draw an arc from this point right here and an arc from this point over here, just like I did from these two. This arc right here and the arc from the other side, I'm going to do something very similar. I'm going to make one from here, make an arc, and I'm going to make another arc from over here. Now, I don't have to make the arc on the other side. I could if I wanted to. The thing is, I already have a vertex. But if I want to make an arc on the other side, take a look at where it ends up. You see how it ends up on the vertex anyway? So you don't have to worry about the arc on this side. You only have to do the arc on this side. Draw it through. And an angle bisector cuts this angle into 2 perfectly equal pieces. Today we're going to make a bunch of angle bisectors. You're going to have a lot of practice with this. You draw an arc across the angle, find your 2 points, draw an arc from each side. Go ahead and grab one of your triangle worksheets, and we're going to do the first triangle, and we're going to make some angle bisectors on him. So take your first triangle, and I'm going to make an angle bisector from all 3 vertices. So I'm going to start with an angle bisector down here. It does not matter how big you make your arc, but I recommend not making it too big. Arc, and that's going to give you your 2 points, here and here. These are the points that are going to determine your bisector. You draw your arc from here, one arc, and another arc. This point and this one determine your angle bisector. Now, when you draw it in, you don't have to draw it very dark. If you draw it too dark, it's going to end up getting kind of messy. I would just draw it nice and light, just like that. You can see I was off just slightly here. This one's probably going to be off by like a millimeter or 2. This, again, is an angle bisector. Cut that angle into 2 equal pieces. Okay. We're going to draw another one from another vertex. I'm going to try and keep it centered so you can see it. Move this over a little bit. There. I'm going to make one from here. And I want this point. Here's my 2 points. One here and one here. This is where I'm going to put the point of my compass. Goes from here, and I make an arc, and it goes from here, and I make an arc. This point and this one determine my angle bisector. And again, I draw it nice and light. I don't recommend drawing it super dark. It just won't look very nice. Just has to be dark enough to see it. And I have one more. This time I'm going to make an angle bisector of this one. Draw your arc. Got an arc. One from here, one arc from there, and one arc from here. I'm sorry? Yeah, we're going to do one from every side. And from each, actually from all 3 vertices. We don't call these the sides. These are the vertices. This one, and this one. And we draw in our line. And when I draw in this angle bisector, I want you to notice something. Did you all see that they all came through the same point? We call this point a point of concurrency right here. This happens to be one of the centers of this triangle. And it has a name. It's called an incenter. And this point right there, the point of concurrency, where all 3 angle bisectors meet, is called the point of concurrency. Mm-hmm. This special point right here in the middle is one of my centers, and it's called the incenter. And it has a really, really cool property that the circle that I make that just touches one of the sides will just touch all three sides. We say that this circle inside is going to be tangent to all three sides. It looks like this. From this center, I want to just barely touch the side of this triangle. I only want to touch it in one point. I don't want it to go through 2 points. I want it to touch just barely. See if I can get it to go there. And we say that this circle is tangent to this side because it just barely touches it. But the nice thing is that it'll just touch this side as well. See how it just touches it in one point right there? And then if I go over here, it just about touches this side as well. Now you can see I'm off, like I said, I was off by 1 millimeter, but it's okay. This is called the incenter because this circle is inscribed in the circle, in the triangle, excuse me. This circle is inscribed inside of this triangle. This circle is called an inscribed circle. Okay, so what you want to do is from your center, you want to measure to the sides so that it just barely touches each of the sides. It should just barely kiss them. And we say that this circle is tangent because it touches at one point right here. It touches at one point right there. And it just touches at one point right there. Inscribed circle. It's called your incenter. Did yours work okay? It just touches all three sides. It's okay. It takes practice. We'll do another practice in a little while. Go ahead and grab another. You should have 2 of these. If you didn't get 2 of them, grab another one. I'll get it for you. Anybody didn't get 2? Yeah. This one is going to be called the circumcenter. This is my favorite center. I think it's one of the harder to get to. This one is pretty easy to find. This one is a little harder to construct. And it's called the circumcenter. I'll write it up here. Sorry. Yeah, we did the angle bisectors. This time we're not going to do the angle bisectors. We're going to do the perpendicular bisectors of all the sides. Circumcenter. So here's what we're going to do. This one is going to end up being messy. There's no way around it. That's why I recommend that you draw them pretty lightly. When you draw these arcs, Freddie? Remember, you have to open your compass more than halfway. It's going to be pretty big because this side, I made the triangles pretty big for you. And we're going to go from the vertex and we want to go more than halfway and draw our arc. Now, if you want to, you could draw the double arc like they do in the book, but I like to just draw the whole arc all the way across. Freddie, close the computer, please. It should be more than halfway, and then this one needs to go more than halfway. As long as they intersect, it's fine. Now, I drew them nice and light so that they don't show up too much. I've got a point here and a point here, and this is going to give me my perpendicular bisector. Looks just like this. You can see I'm slightly to the side. I'm about 1 millimeter off again. Hopefully it isn't too far off. This is a bisector. It cuts this side of my triangle into 2 equal pieces, and it's 90 degrees. So I'm going to draw another perpendicular bisector. I need to go more than halfway across this side. That's quite a bit more than halfway, so I'm going to go ahead and cut it. I'm going to make it a little bit smaller. That looks like it's more than halfway. And I get an arc and another arc from the other side. It doesn't matter. It doesn't matter how big it is, as long as it's more than halfway. It's pretty big. Is that better? There's this one, and this one. And again, draw it nice and light so that it isn't too messy. We have one more perpendicular bisector to do. I have to do the perpendicular bisector of this side. Go more than halfway. Here and here. And again, it doesn't have to be very dark. Now what you're going to see is that this point is your point of concurrency. What are you confused about? We're doing perpendicular bisectors. Okay. From this side, you go more than halfway and you make an arc. From this side, you go more than halfway and you make an arc. That's all. And then you join the 2 points. This is a point of concurrency. Of the perpendicular bisectors. Of a triangle. And this is my favorite center. You're going to see why in a second. Even if you only got 2 of them, you're still going to get the right place. It's just, it's a lot nicer to have all 3. Now I need to zoom out a little bit so we can see it. Here's what's nice about a circumcenter. You'll notice that this one is a lot closer to this side than it is to these sides over here. What ends up happening is this point should be the same distance to all my vertices. Here we go. Take a look. Here's how far it is from this one. And it should be the same distance to this one. And it should be the same distance to this one. I'm a little off, you can see. Oh, there it is. That's why. There's my point. Sorry. Here it is. There it is. 1. And that one's a little off too. Let me see. I can see it pretty good. There he is, right there. Now I can see him. I'm a little bit off on my point here. Let me see. There, that looks a little better. There it is. I had to take my glasses off to see where it is. Now, when I draw this circle circumscribes the triangle. It goes all the way around it, and it's exactly the same distance from this point, and this point. If I wanted my restaurant to serve 3 different towns, and they were similar to this triangle, I would put it right here so that it's the same distance from all 3 towns. And that point is called the circumcenter. Okay, don't worry. That's why we practice. You're going to have 2 other triangles to work on, and you guys are going to do this one in a little bit. Now, what I recommend you do is while you're doing your Ed puzzle, today's Ed puzzle, the teacher, when he teaches this one, he actually does this freehand. He does it completely just estimating where his bisectors are, and he estimates where his perpendicular bisectors are. Now, my recommendation is that you go somewhere in between, and I'll show you what I mean. If you guys will open this up to where it's the in-center, sorry, this thing. Open up your packet to where the in-center is. I think this is it. It's on page 268. Yeah. Now you can see I did one already. I did this one almost completely freehand. All I did was I estimated where the middle of my angle was, and then I just drew it in. I estimated where the middle of my angle was, and I drew it in, and I estimated the middle of my angle and drew it in. These are not constructed. The problem with doing construction in a triangle this small is that you're going to get a big mess. It's going to be really hard to see it. For me, I just estimated where these angle bisectors will go through. This is page 268. And we are looking at the in-centers. I'm going to try one more. You might want to do this one with me because it goes really fast. Good. Take a look. I want to get in the middle of this angle. I want to cut this angle in half. I'm going to see how close I can get. Looks to me like that's pretty close to the middle. Now, when I draw it, I'm going to see if it looks like it's in the middle here when I draw it. Let me see. That looks pretty good. It looks like this angle is pretty close to the same size as the other one. Now I'm going to try and get the middle of this angle. Looks like that's about in the middle. And I want to get this one in the middle. Looks like it's about here. Looks to me like my in-center is pretty close to the middle there. Now I'm going to check it. Let's see how close I was. Here's an in-center. It should just touch each of the sides of my triangle in one location. Looks like, see, here's the problem with making these so small. It's really hard to get it to go. Yeah, it's going to be off a little bit. Yeah, it's quite a bit off. That's because I didn't construct it. I just estimated it. But it should be closer. Let's see how this one is. Maybe I got this one a little bit better. Looks like that one's pretty close. Okay, a little bit closer in. Let's see. Oh yeah, this one's much better. Yeah, this one's a lot closer. These are in centers. The next one I'm going to look at is the perpendicular bisectors. That one's actually, I think, at 265. Yep. Now what I did is I just estimated where my perpendicular, no. Go sit down.
I just get out from Andreas.
I'm sorry?
Can I just not get it from Andreas?
What are you getting?
The word.
What do you mean?
Can I use the bathroom?
Not right now. For this one, we want the perpendicular bisectors. She doesn't. She's actually going to be counted absent. Now, I estimated my midpoints. These are the perpendicular bisectors. What I did was I estimated my midpoints, and then I estimated what the perpendicular lines look like. So I'm just estimating them. I'm going to do one down here so you can see it. I'm going to estimate my midpoint. Looks like this is about 4 centimeters. So my middle is right there. My middle is right here. And the middle of this side is right here. I estimated my midpoints with just a ruler. Now what I'm going to do is I'm going to estimate where my perpendiculars are. I want this one to be perpendicular to it, 90 degrees. And I want this one to be 90 degrees. And I want this one to be 90 degrees. And what I should get is my circumcenter. Let's see how close I am. Hopefully it isn't too far off. This one, oops. Let's see, here. Little bit off, not too bad actually. Just a slightly off right there, but not bad. This is not constructing. This is just sketching them, just like on your Ed puzzle today. When you take a look at his Ed puzzle, he does these freehand. I'm actually using my ruler a little bit. This is going to be due on Thursday. For now, make sure you do this circumcenter, Andres, and the in-center for these two. This one and this one. These are actually by construction.